Okay, so now I will be explaining the level 1 of the code. So this code is divided into three parts. So the level 1 is about identifier recognition using DFA. So level 1 is used to check whether a given string is a valid identifier or not. DFA is valid for validation based on predefined rules. A valid identifier must start with a test case and can contain letters and digits. So let's take with an example. So let's run it right now. So now as you can see, so let's take total one. So total one is an valid identifier as it starts with the letter and contains only letters and numbers. So it is a valid identifier, and this is the positive test case. So let's run it again and check for the negative test case. So let's take an example of one total. So here it shows that it is an invalid identifier as our language CFG says that uh, only it should start with alphabet, not with numbers. So it does not start with it. So and so it is an invalid identifier. Let's get to the level 2. So yeah, this is the level 2. Okay, so level 2 is all about mini lexical analyzer. So level 2 performs lexical analysis on mini ADC program. The lexical analyzer scans the input and divides it into tokens. Tokens are classified as keywords, identifiers, numbers, operators, and delimiters. This phase helps the parser understand the structure of the program. So this is the code for the level 2, and let's run it and let's see the output. So in level 2, let's take a positive test case as x equals to 10. So the identifier here we can see it's divided into tokens, that as identifier is equals to x, operator is equals to y, sorry, operator equals to number equals to 10, delimiter is uh, semicolon. So as we can see here, it runs properly and it is a positive test case. And let's check the negative test case also for the level 2. Here let's take an example of x at the rate of 10. So as we can see, identifier here is x, invalid is at the rate. As we can see in our defined CFG language, there is no at the rate. At the rate is not a valid operator in mini ADC language. So this is a negative test case. And now let's be going to the level 3. So level 3 is like lexical analyzer and parser. So this is the code for the level 3. Level 3 checks whether the mini EDC program is grammatically correct or not. So CFG, and here we cannot use DFA. DFA is not possible for level 3. So we use PDA push down automata. CFG and PDA concepts are used for syntax analysis. The parser validates declaration, assignment, and print statements. If the input follows the mini ATC grammar, the program is accepted, otherwise it will be rejected. So this is the code for the level 3. As we can see, it is very detailed code. Let's run it and check whether it works or not. So for let's take a positive test case as begin int x colon x equals to 10 plus 20, print x and okay. So let's see what happens. So it says that program is accepted here. So this is the correct program, and let's check it for the negative test case. So for the negative test case, let's take begin int x equals to 10, and so the program is rejected as the semicolon is missing after the declaration statement. So this is a negative test case. This is the mini ADC language. Thank you.